and as they write computer programs and to process data. So understand what's inside the data are the rules. So let me just start the topic. Okay. Basically, I'm from in NCKU. So if you chat with me, please come via email or everything's fine. The topic we can start from the artificial intelligence. It is not, but we actually concept or stories from kinds of movies. There in 2001, it says there is what is AI? Artificial. So someone says that definition says an artificial creation can learn, reason, natural language. Okay, so basically, we try to or even a program so that we human users talk, program the robot can understand what we are talking about. So it's no such can use our smartphone. We can talk to our smartphone can help us to do some web search or to do some map search, such as Google Maps services, something like this. So it's the understanding of natural language. SOC means understand. Okay, so that as a feasibility by these computer programs, but as a developer, our challenge of the understanding of different languages, especially in different sentences or events or something like this. Let's go through more details in this talk. Okay, this is my second time talking about this topic. So when we had whose topic is very related topic today, artificial intelligence is basically and puts two snapshot here on the slide. We can see the difference from the figures, and we can see the change to artificial intelligence. So what is you are intelligent intelligence. So to this noun, intelligence, acting smartly, originally. Okay. This viewpoint, when we are human users, we think that we are so smart to understand everything, generally process all the math, so that when intelligence, when we so-called are going to let computers, just as we human, we can see here, artificial intelligence, like thinking and acting smartly, humanly, rationally. But are humans rational? We humans are usually not 100%. This is a very critical conflict. When we move to the right figure, else of this, when we think and act humanly, rationally, what can we? Okay, so there are cell computer science, of course, in psychology related research area. So I think here is a bridge to connect in my area computer science and in your area psychology. Okay, point of this. Okay, and in the following slides, I will not about technical details. Instead, I try to explain some to you guys, so that we can a main concept says machine learning. It's because to learn from data. Another page like this this once had a topic page like this. When we so much data, how can we data? Just like this figure, the man his planet for his flower. And on the left, it says businesses, government, and society are on the tab. So everyone, the data is with potential value, but how can we the real value? Okay, so we talk about this to explain the topic of AI is artificial intelligence, just as we said. Okay, so they is with the following outline buzzwords, just like that, and we try to explain to you guys a general flow and try to show you what of data mining tasks to cluster data and to learn part of data. And finally, I'll give you some concluding remarks. So I pace faster here, okay? Because on our previous pages, as to guys. Okay, then there are like we can see in this data science is the biggest one, and around learning, analytics, machine learning, engineering, statistics, social consumer demands, blah blah blah. Okay, this relate. What is the difference? What are of this topic? Graduate student in the computer science field, we try to get a common topics. This is today. Okay, so we from relevant topic, which it says DM and machine learning. It says ML. Okay, we can give a conclusion that they are a brotherhood, just like a big brother. Even there are two different areas. That these two fields of theoretical and practical tools. It means you many theory deeply understand the data, or try to make complicated system to process the data. And the system are very deep, simple. But of course, this is not common people for everyone in our society to use several practical, it means technical oriented, to brought several in a country, in a society, can use so-called the data mining result, the machine learning result, especially on our smartphone. Many apps, applications are planning that they are with the artificial intelligence feature. They can understand what we user need, something like this. Okay, so here we try to tell stories to illustrate key differences and common concept of these two areas, data mining and machine learning. Okay, so here the slide is very important for you guys because we are connecting from learning to the concept of machine learning. Learning is talking about how we human users learn, even when we are a young kid. Okay, so here there is a flow says we start from observations. Imagine that when we are maybe 3 years old, we try to observe everything around us. We can see new animals, new people, new stuff in my house, or bring by my parents, bring by my friends. Everything is so new, so interesting for me. Okay, so I use my eyes, my ears, or my nose to get some observations. So here is the input. Observations are our input to facilitate our learning process. Then we use our brain, our little brain, because we are only 3 years old. Okay, try to organize what we understand, what we perceive. And finally, after several times of practice, we develop a skill. Okay, so for a 3 years old kid, when he or she can say, mommy, daddy, or a dog or a cat, it's a skill, right? Okay, but when we grow up, the skill becomes more complicated. Maybe we can swim in a pool, or we can ride bicycles in the park. That's our skill. But when we learn to swim, learn to ride bicycles, we have several experiences of failure, right? But we simplify the whole flow. Then this flow is from observations as input, learning as the main process, and finally the output is skill. Okay, so let's go to the bottom part of this slide. It says machine learning is a similar process, a similar flow. It says that we start from data. Data is our input. Then we develop several different machine learning or data mining techniques. And finally, we let the computer, let the machine have a skill. Okay, so basically, we put two flows here to let everybody knows that the flows are so similar. Okay, so we can go to more details here. And our next question is, what is skill? For computer programs, the skill is to improve some performance measures, or something like prediction accuracy. Okay, so in the field of computational finance, it's in the College of Management, right? We can input some stock data and use some machine learning data mining techniques to make more money. If you can do this, then our skill is wonderful, because our data can make money, right? So here, the red part, the machine learning data mining techniques are the critical section in this flow. So how to make original data, raw data, into money. Okay, this is a very practical issue in our world, right? So let me go on. I try to let every one of you to practice a topic like what we see here. It's called recognizing animals. So the question is, what are these animals? Can you guys say from left to right, what are the 3 different kinds of animals here? Okay, we can have some seconds for you guys to think about this, and based on your experience or heuristic. But here, the caption in small words already tells us the answers. From left to right is duck, goose, and swarm. This test is not so easy for especially Taiwanese, because in Taiwanese, the names of these three animals are so close. If you have learned some Chinese, it says 鸭子, 鹅, and 天鹅. Okay, so the names of these three different kinds of animals are so close. So everyone here in Taiwan, say Taiwanese students, cannot easily distinguish one from the other, usually. Okay, so when we try to do this, we can have the possible solutions as follows. The first one is to define each of them. It says all dogs are with a short neck, and their feathers are gray or with several different colors. And on the other hand, for a swan, the neck is very long, and its feather is white, like very beautiful bird. Okay, something like this. Okay, so when you try to make these observations and try to put them into a computer program, I think this solution is very difficult. Why? Any of you, even you don't write computer programs, you don't know what are computer languages, or you don't have to know these expertise skills. You can understand that the computer program must be very complicated. And even if this computer program is complicated, the precision, the accuracy cannot reach 100%, because we always encounter some fuzzy images, or when we think in another way, if we add more kinds of animals here, when we have only three kinds of animals, our program can do good job. But if we add 2 more, 3 more, or in total 100 kinds of animals, what is the accuracy of our computer program? So everybody knows that it's not easy, because this program must be very complicated, and it's not always good result, good skill. So that we try to use this example here to illustrate the last line here. Another solution is better, because another solution is to learn from data, or just learn. For our human users, we just look more pictures. We can learn, these are dogs, and this one is a goose, something like this. Okay, so when I brought my kid, when he is 2 years old, he can do a good job on recognizing animals. So here's the proof. This is my kid when he is 2 years old, say 5 years ago. Okay, so here's the photo at that time. He is with 2 goose right here on the park, in the park, on the grassland. Okay, so I'm talking about this is a desired approach to solve this problem. Okay, so when we move to the next slide, I'm going to say that we can redefine the flow to say, from data, machine learning techniques, we can get improved performance measure. Okay, but what are the questions? What are the appropriate questions to utilize, to use a data mining technique, to use a machine learning technique? We have 3 criteria here. The first one is there are some underlying patterns to be learned. Okay, because we have some underlying patterns, so that we can improve our performance measure through practices. In the first time, our performance may be not so good, but in the second time, we become better. For the third time, fourth time, etc., we can try to improve our performance gradually. This is a process very like when we try to learn to ride bicycles or try to learn to swim, right? Okay, so there is some tricks. Here says underlying patterns to be learned. Okay, and the second criterion is but no programmable or easy definition. Is if a question is with a very easy definition, very clear definition, we don't have to use data mining machine learning technique. We just follow the definition to complete the desired tasks. It's okay. It says when we try to use our mathematical background knowledge, we can do several jobs in our daily life. We don't have to use data mining machine learning techniques. So in this second criterion, what we try to say is the problem should be difficult enough, not an easy problem. Only when the problem is very difficult, we try to use data mining or machine learning technique. And the third criterion is a very important one. It says somehow there are data about the pattern. Because if there is no data, we cannot learn anything. It says, if you can have some observation, we human user cannot learn to do similar activities, right? For example, in Taiwan, the weather is always very hot, right? So we basically cannot do ski very well, because in the country there are snows in winter. People there can do ski activities very well. But in Taiwan, it doesn't snow, even in the coldest winter. Okay, so we cannot be a very professional, very good ski player in Taiwan. If we want to do so, we have to go abroad to a colder country to learn to practice our ski skill, right? Okay, so when we move our focus back to this slide, in the third criterion, it says we must have data. If we don't have data, we cannot use data mining machine learning technique. It's a very simple idea. Okay, so it's a quiz time. Please try to answer this question. Which of the following is best suited for data mining or machine learning? The 1, 2, 3, 4, the 4 options are different questions and very common issues in our daily lives. Say the first one is to predict whether a baby cries in the next 5 minutes. If you ever have a baby, it's a very important question, because you can understand what is the mood of this baby, or what does he or she need. Okay, and then the second option is to determine whether a given graph contains a cycle. It's a very classical computer science question. And a cycle means starting from one point, you can go through the path the links, go to another node, the second node, the third node, and finally you can go back to the original node. If you can find a path like this, it says, there is a cycle, okay? And in the third option is to decide whether to approve credit card to a customer. So everybody knows how credit card works. You can buy something without paying money at first, and after a month, the credit card company or bank can send a bill to you, says, here is your bill, saying that, you have to pay $5,000 because you bought something like this, and this. Okay. But in this option, the background knowledge is that sometimes the banks cannot receive the money from some customers because these customers don't have enough money, so that they are not so good customers for the bank. So in the beginning, the banks should have a criterion to determine someone is very good, is very trustful, so that I better give him a credit card. But some other users are not so good. I better reject her to apply the credit card. Okay, and the final one, the fourth option is to guess whether the Earth will be destroyed by a misuse of nuclear power in the next 10 years. Okay, what is your answer? Do you have an answer in mind?
I think it's the third one.
Oh, good. What is your reason?
Because I think there's some pattern about the customer credit, like the income and his previous behavior or something.
Okay. So, is there anyone have a different answer?
I also think that for DM is for the number 3.
Okay. So, what is your reason to reject the other options?
Because for other options, I think it takes more information to determine like whether the baby will gonna cry, because it takes predictions. But however, for the bank credit account, they have some kind of pattern of a customer. So we trace back from the database to understand, yes.
Okay. Thanks for your sharing. So we can move on. Okay. For me, the first, the correct answer is, of course, number 3. So every one of you is with a good choice. For the first option, we usually believe that a baby cries or smiles randomly. So in the first second, he smiles, and in the next second, he cries. So this is based on my experience, because I have 2 kids. It was a terrible period when I take care of them. Okay, I'll take care of a baby. And for the second one, the reason is that a given graph, to determine a given graph contains a cycle is with a very clear, very easy definition, so that we can just use some existing algorithm to accomplish this task. We don't have to use data mining. We don't have to collect a large amount of data first. And for the fourth one, we don't have data because we have only one Earth. So that if we don't have data, we cannot use data mining algorithm to do the following work. Okay, so the third one is a very classic problem in our field because even when a customer is very rich, sometimes he doesn't want to pay the credit card bill because he's not trustful. Okay, so that we can try to use some algorithm to fully utilize the feature and try to get the underlying pattern of this topic. Okay, let's move on. Now I'm going to say to talk about general flow. Okay, our start point is data overloading problem. It says that there are many different machines or human employees help to collect different kinds of data. But for company owners or data owners, they are just out of fear to collect the data. They don't have several good employees or effective approaches to analyze this data. So that we can see in the second point that data volume grows so fast that all data are never analyzed. It's a common phenomenon in several companies here. Okay, so when we try to establish a database system, we can do some queries, but when our data becomes more and more, we cannot do some different queries like the following. It says, who is likely to buy product X? I can try to understand, product X is more welcome for our customers as compared to product Y. This is a very easy question, a very easy query. But when we try to answer this query, who is likely to buy product X? Actually, we don't know. Okay, and for the second question, list all reports or problems similar to this one. This question is usually encountered in factories because the machines, the manufacturing machines may encounter some problems occasionally. So we try to figure out the solution of one problem, and then we try to use this on other problems so that our machines can work properly. Okay, but even to identify similar problems is not easy for a human user, for an experienced user. So that this kind of query is usually not easy to be answered in database systems. And the third example is to flag all fraudulent transactions. It's not very easy, but it is a main task for insurance companies, for example. Okay, so everybody knows that these important questions cannot be easily handled, so that we have to utilize data mining or machine learning techniques, even if we don't know what these techniques are exactly. What are these algorithms until now? We can have a concept that these are important questions. We have to solve these questions. Okay, so let me show you some interesting figures to demonstrate this word. Say we are drowning in data but starving for knowledge, because in our daily life, there are so many paper documents and so much data in our computers. But it's just like the little boy in the right figure. When you are in the ocean, in the sea, it is so desirable to have a bottle of clean water, because we cannot directly drink the seawater, right? Okay, so when we are drowning but starving, we need an effective and efficient approach to handle so much data. Okay, here is the start of our question. And the workflow is like this, but it is a very ideal flow. So for the first step is to get data. The second step is to clear, prepare, and manipulate data. And in the third step is to train a model. And the fourth step is to test the data against our model. And finally, if our model is to be improved, we try to put more efforts on this. And finally, hopefully we can have some wonderful results. Okay, but here I try to emphasize that this is an ideal workflow, not a very practical flow, because a practical flow is like this. Every steps, when we do some steps in this flow, we can encounter a situation that we have to go back to the earlier stage. When we have the original data, the raw data, we try to do some pre-processing steps. And finally, we come to the data mining algorithm and get some patterns. But if the result is not good enough, we have to go back to the previous step or at an earlier stage. Okay, so actually, according to my experience, if the whole process starting from the raw data to our endpoint is 1 year, we have to spend maybe 7 or 8 months to handle the earlier steps here. And the data mining is only a tiny step here. So this job is not as everyone think. So we can just put our data into a black box, and the magic box can help to generate so-called knowledge. So it's a very easy task to be feasible to utilize data mining or machine learning techniques, just as we use the black box. Okay, it's not so simple. We have to spend many effort or much time doing with the data pre-processing steps. Okay, there are different choices when we handle these steps. Okay, and I try to emphasize another point of here. When we have some result, have some patterns from data, we try to evaluate or interpret them into actionable activities. It is very important, so that we can transform patterns into several activities. Okay, something like a promotion activity for chain store or for travel agency, so that customers are willing to spend more money when to buy their product or something like this. Okay, so the last step step. Interpretation, evaluation is very important. Okay, then I try to illustrate some examples here. He says, classification, prediction, clustering, association. These are not so easy to understand. What are these tasks, or what are the differences between one from another down. So I purposely put prediction first, because prediction is usually limited to a time series prediction. Just as we see here, the time series could stand for a stock index in different time point, set in different year. Okay, so the real variation of the stock index is in the black curve, moving upwards and downwards like this. So a very easy algorithm to accomplish the prediction task is to find a fit line. A simple fit line is to use one straight line to fit the real curve in black. But obviously the blue fit line is not good enough, so that we can use a more complicated fit line, just like the red one. The red curve is a better fit line. So once we have these fit lines, we can try to extend the fit line to the right, so that we can predict or try to forecasting future value. This is simply how prediction works. Okay, so the algorithm, the keyword here is to do regression here. Regression is to find a fit line for several data points. And then we programmers can decide if we want to use a linear fit line or a more complicated fit line, like this. Okay, here is an example of making a prediction or a forecasting to future values. Okay, and second one, I try to show you an example of classification. Classification is a similar task, but here we have several predefined categories. So in this example, we have only two categories. The one on the above is honest. We say, we get 3 different faces, but all these 3 users are honest. And the other category is crooked. It says we collect three more different faces, and the 3 below are crooked. So my question is, which characteristics distinguish the 2 groups? When you see a new face, said the seventh person, how do you distinguish to determine that he is honest or crooked? Okay, of course this is an oversimplified example, because we cannot just see the face of a person to determine if he is honest or not, right? But in our limited data, we can try to make some practice here. Because we only have 6 faces here, so that we can just observe their heads, their eyes, or are they with a smiley face, or are they wearing glasses. Okay, something like this. Okay. So the solution of this example is honest is defined by once a face has round eyes and a smile. Rules in the model. Because in this model, we just like a very young kid. We have limited of data examples. So in our example, we can just figure out this simple rule. Once I see a face, his eyes are round and he's smiling at me, I think he is a good guy. He's honest. I can trust him. Okay. Of course, when we grow up, we don't use this rule, right? Because it's very dangerous. Okay, but in this example, the rules can achieve 100% accuracy because the rule can apply to all these 6 faces, no problem. Okay, so this is a classification task. Okay, but once we look into a more practical example, our data may be shown here in this table. It says that we can collect the features of different students, and each student is in one row of this table. So the first student is short and with blonde hair, and is with blue eyes, and this student, the first student, is classified into class A. Okay, and the second student is classified into class B, etc. So here, once we have the 8 different rows here, our question is to ask, what is a criterion to determine have 3 different values of blonde, red, and dark. Okay, so when we choose hair, we can have 3 different branches. The left one is dark, the middle one is red, and the right one is blonde. Okay, and we totally have 8 students. When we use their hair colors to separate them, we have 3 students with dark hair, 1 student with a red hair, and 4 students with blonde hair, like this. And in this example, we can see that the 3 students with dark hair are all class B. It's a very perfect division. And the one with a red hair is class A. It's also wonderful because we completely classify dark haired and red haired people. Okay, so in this example, what we have to do more is to handle the rightmost group of 4 people or 4 students here, because there are 2 A's and 2 B's. So more work is required. Okay, so then we can use the eye colors to separate them. Okay, so in our raw data there are 2 different eye colors, blue and brown. So when students are with blonde hair and a blue eyes, they are all classified into class B. On the other hand, when they are with brown eyes, they are all classified into class B. So until here, we have accomplished we have built a decision tree completely based on our 8 training examples. Okay, so here is the final decision tree. And in this decision tree, our rules are can be extracted from this tree. Say there are 4 rules. The first rule is the hair is dark, then the student is class B. The second rule is if the hair is red, the student is class A. And the third rule goes through this path, and the fourth rule goes through this path. So in this algorithm, making a decision tree, we can build a decision tree first and extract rules according to all traversal passes. Once we have 4 passes, we have 4 rules, or something like this. Okay. Of course, if algorithm is smart, we can have a word decision tree, and this tree is more complicated and cannot reach a general conclusion for the 8 training examples. Because in our raw data, we only have 8 students, but in this tree, there are 1, 2, 3, 4, 5, 7 nodes, so that we cannot summarize the data effectively, because each one node is only mapped to 1 student. It's not a general rule, so that we can call this decision tree one. Okay, so in computer science, we try to several details using algorithms like this. But we in just today, I don't want to bother you, so that I'm not going to talk about more technical details here. When interested, you can have a chat with me often. Okay. And then I'm going to talk about third example question, is to conduct clustering. So what is a cluster? A cluster means groups of records with similar characteristics. Okay, or these characteristics are most frequently occurred in common. Okay, so here we have an example, and it says in a supermarket around 5 p.m. on Fridays, we usually observe that beer diapers are commonly bought. Okay, so if we try to, who are the customers bought beers and diapers together in this period, we can have more examination into our data. But this problem is very related to our last example, said association rule techniques. So let me go through some details here. So let me show you a very easy example of clustering. Once we have several data points, and we can use the data point, use their values firstly to depict them on a data plane. It says the first data point is 36 and 10, and the second point is 12 and 8, or something like this. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or 10 points in total, so that we can firstly plot them on a data plane. And finally, we can use our heuristic, our thinking to circle nearby ones, so that in this example, we have 3 different groups circled by green lines, and 1 outlier. This one is not belonging to any of the clusters. Okay, so it's a very simple example of clustering. Then I try to demonstrate to you guys the concept between supervised and unsupervised learning. When we talk about supervised learning, it says the task is usually data classification. It means the term supervised means that we have to provide some training data, and we have to make data labels to indicate the class of each data point, so that our goal, our purpose is to classify new data based on the training results. On the other hand, when we talk about unsupervised learning, we are talking about clustering because the labels are unknown. We don't have training data. We just put our data all together and try to separate them into different smaller groups. Okay, so unsupervised and supervised, the difference is very obvious. Okay, so here is a roadmap for beginners to start with some data and try to become a data scientist. He probably has to learn some database techniques, or try to understand what is an algorithm, what are the data structures, or what are the statistical models, or something like this. But here I just use this figure for your reference, not to illustrate the details here. And I'm going to the end of my slide today. Sorry that I spent too much time. There are more, but I use several simple slides to reach my concluding remarks. First one is talking about AI, the starting question in the talk today. We have different generations of AI developing. Okay, in 2010 to 2015, there are several techniques developed by computer scientists, something like deep learning or SVM tools. These are very successful algorithms in our field. And in the second period, AI becomes competitive. Once you may heard the AlphaGo beat all other human users in the Go game. And several big companies become AI first, such as Google, Apple, Amazon, Microsoft. All these companies try to develop their AI team, try to promote their products, says all their products are with AI features. And we are in the third period. We try to make AI necessary. But we don't have to be afraid of being replaced by AI, because we human users should learn to use AI to work with AI so that we can reduce our burden of doing repeat and repeat daily jobs. And we can use AI to transform data into actionable activities to get some performance improvement, just as I said earlier. Okay. And once you don't really understand what a machine learning project is, we can use another example to show you that when we're doing a machine learning project, it's just like we cook something. The above is how we make a dish. We try to get some ingredients. We spend several hours preparing these ingredients to dice, to wash them, and finally we can cook them and put them on a plate or on several different plates. Once we have several years of experience, we can become a chef with a recognized expertise. Here is how we become a cooker, a cooking chef, right? So similarly, when we are doing a machine learning project, we're starting from data, and we try to do some data engineering steps. It's just like data pre-processing steps in our previous flow. Then the machine learning or data mining algorithm are the central part of this flow, just like cooking to make dishes. And finally, we have some architectures or some web programming environments to demonstrate our learning results. And finally, we use some domain-knowledges to explain the results to all the users, just like a chief to demonstrate his dishes to all customers in the restaurant, right? Okay, so that we can simplify the whole process and don't be afraid of machine learning project, saying that, I don't write computer programs, I know nothing about this, so I cannot be familiar with all kinds of this. It's not a correct identification, correct concept. Everyone can use AI, everyone can understand what data mining, machine learnings are, even if they are not familiar with computers or computer programs. Okay. So finally, I think in my experience, problem formulation in different projects is usually the most important and challenging step. My graduate students don't have a topic at first. When they are writing their thesis, they usually put their topic in the last few days, just before the oral defense examination. Okay, so it's very interesting in that we just doing some jobs, some tasks to approach our rough goals, and finally, when the goal becomes more clear, our topic can be determined. So once you are interested in today's talk, you can go Google search this topic on the here. How Target figure out a teen girl was pregnant before her father did. It's a very promising topic to attract users to know the background news. Okay, but it's a wonderful story once you have to, or once you want to know something about data mining or the successful story of a chain store, a chain grocery store. It says Target. Okay. And finally, there are references here. If you are interested, you can go see some YouTube clips or try to get some other references here. Okay, sorry to show all the style of long period. So any questions?
Nope. So far, it's all good.
Okay. Basically, in my daily jobs, I'm doing some database systems. I'm working to develop some information systems with my students and with industrial partners, so that once you have a demand or need of collecting data, we can have some more chat here. Okay. And I guess May has my Line account. So once you need, you can contact me using Line, or just email to me. Okay. So I don't know how this course works in previous weeks. Are we going to stop here or make some discussion? Okay. Sorry that for most of you, this is the first time of our meeting. So I don't know if my talk helps in your project or in your research topic. So once you can have a question, just let me know. Okay, that's fine. Or just I can put my contact information here, so that I can end our meeting today here. It's my email addresses, email address and my Line account. It's WGTENG. The abbreviation of my my English name. So hope to talk to you guys later or someday. Okay, thank you.
Thank you，谢谢老师。
Thank you，谢谢大家。
Thank you.
Thank you。
Okay, see you. Bye.
Oh my god!